Okay, let's try this again. Today we're going to talk about literal equations, and we're going to start by talking about equation operations. Remember that we can do anything to one side of an equation as long as we do the same exact thing to the other side of the equation. Now, if we have addition, we need to remember that that is undone by subtraction. If we're having subtraction, that is going to be undone by addition. Multiplication, undone by division. And, of course, division, that is going to be undone by multiplication. Okay, all these rules work whether we're dealing with numbers or variables or whatever. So let's try a real easy one. We have 2x equals 12. Okay, clearly here, this is multiplication. So we know from what we talked about on the other page that multiplication is undone by division. So we're going to divide both sides by 2. We get x equals 6. Okay, so pretty much how that works with numbers. Sometimes we're not going to have numbers. Sometimes we're only going to have letters. So let's take the area formula. Area equals length times width. And they're going to ask us, when we have these types of equations, to solve for a certain variable. For, in this case, we're going to solve for w. Okay, so the first thing we need to do is we need to look at this equation with the w on this side and decide what's going on here. Right here, what type of operation do I have going on? Well, it looks like I have multiplication. So I know from what we just discussed and from what we've been doing for years with regular equations that multiplication is undone by division. Now I want to keep the w. Okay, if I was to divide the w, I would put that, it would end up in the denominator on the other side, and that would cause a huge mess. So we want to kind of leave the w, or whatever we're solving for, on the side that it's already on. So I'm going to divide both of these sides by L. Easy enough. Those L's cancel out. I'm left with A divided by L is equal to W. And that is my answer. They asked us to solve for W. We did that. So that's what we're asked to do, and that is what we're going to, where we'll stop with that. There's not going to be a number answer. It's just going to be a rearranging of the equation. Okay, on the sheet that I uploaded yesterday, one of the first problems they asked for with the literal equations is they give us this problem and they ask us to solve for x. So as we can see, we have a mixture of things going on here. We've got subtraction, we've got multiplication, and our job is to get this x by itself on one side of the equation. So I'm going to start by getting rid of anything not directly attached to the variable. We always talk about that with two-step equations. It works here even though there are no numbers. So I'm going to add b to both sides. Got to get that b moved away. It's not directly attached to the variable. I have a times x is equal to c plus b. Okay, so now my job here is to get this x by itself. The only thing I have left here is multiplication. So it looks like a little simple division is going to work to get that x by itself. Now remember, we can leave it like this, but we're dividing by both the c and the b, so they have to be on the top of the fraction in the numerator, and the a has to be in the denominator. X is by itself. That is what they asked for, so I am done here. All right, let's try one with some numbers. This one ought to look familiar. Area equals 1/2 base times height. And they want us to solve for h. Okay, so we've got some things going on here. We have numbers. we have a whole lot of multiplication on one side, and we've got to get this h by itself. I am going to look at this very first, and I'm going to get rid of the number. That's going to be my goal here. So what I would like to do to get rid of that 1/2 is multiply by the reciprocal. So I'm going to multiply by 2. So now that I've multiplied these by 2, my number is going to cancel out and give me a 1. And we know that in multiplication, 1 just means that anything times 1 is itself, so it just kind of disappears. Over here, I have 2 times a, so I'm going to write that out just like that. Over here, I have b times h left. Well, it looks like they want us to solve for h. We're down to, looks like one step. This is multiplication, so we will divide by b to get rid of that. And we have h is equal to 2a over b. Now let's ask ourselves, have we done what they asked? Yes, we have the h by itself. We do have the h by itself over here. So we are done with this problem as well. And the last one we'll do today also has a mixture of things going on. This is a number 13 on your sheet, in case you're following along. And I have, this is actually the formula for perimeter. Perimeter equals 2 times length plus 2 times width. We're going to solve for W. Okay, so we've got, once again, many things going on. So I'm going to get rid of anything that's not directly attached to the variable. This is the variable in question. So we're going to go ahead and get rid of this 2L. So I'm going to subtract 2L from both sides. And that gives me P minus 2L equals 2 times W. Okay, getting closer. Only thing we have left here is the W and the 2. So I'm going to divide both sides by 2, so I can get that W by itself. Now remember, when we're dealing with numbers, we deal with this with slope a lot. When we have to divide out to get the y by itself, all things on all sides are going to divide by that 2. So that's going to give us just W on this side, and that's good because that's what we want. Over here, P over 2, there's nothing's going to happen there because there's not, P and 2 do not divide. But here we have 2L divided by 2. Those can cancel out, so we're going to end up subtracting just a plain L. All right, we have W by itself. That's what they've asked for, and so that is our final answer. These literal equations are on the LEAP test, so make sure that you're paying attention to what you're doing. We do use this a lot in slope also, which I'll go forward and talk about when we get to our slope review. So just a little review on literal equations. Y'all have a good day.